Hello everyone. So let's see advanced SQL queries part 2. So yesterday we have discussed the part 1 and now let's see the part 2. So in this first topic will be recursive queries and we can say that generating hierarchical data. So now our requirement is, let me show you in the Excel file. So this is a particular one date is there, right? And now our requirement is we want to generate the hierarchical date from 112023 means 1st January 2023 to 31st of December 2023 like this. So it will be 365 days, right, in a year. So we want 365 days and one column which name we can give as a date column, right? It will be a date column. So this is our requirement, right? So now let's see in the SQL. So for that we need to write the recursive city or recursive query for that, right? So we are casting the 1st January 2023 as a date. So this will give us the first date, right? First date as per the Excel file. Now what we have to do, we have to write the union all operator, and now for every time whenever we are going to the next date, we have to add plus 1 day into the original date, right? So in this particular date we need to add plus 1 day every time, right? And this one is called as an anchor member in recursive city. So now how we can do that? So to add the plus 1 date into this particular column, we can write the date add function, which is a date function in SQL server, and we need to add 1 day into that. So day, it will have a, let me show you over here, date add 10. What are the different parameters it supports? So our requirement is we need to add only 1 day, right? So we'll take day, then comma 1 day, right? And then comma this particular column we can use over here, right? And now from this calendar city, till which date or till which time of period we want to retrieve every time. So 31st of December 2023 will be our last day, right? So whenever we will achieve this particular date, the loop will exist, right? The loop will exit and it will give us 112023 to 31 December 2023 data. And now this is our main query anchor member. This is, you can say, the recursive member, and then this is a recursive query. So where you can go to, you can write this column name over here, and then from calendar order by date value, right? So it will iterate whenever the date value is particularly this one. So it will print this date and it will exist, right? So now let me show you up till here. So now what will happen? So if you run up to here, then the query is generating some error, right? Query is generating some error over here. Let me show you that error. So which error it shows? The statement terminated the maximum recursion SQL server is supported is 100 times only. Has been exhausted before the statement completion. So now what we will do over here? So for that purpose, we need to write one additional condition, which is option max recursion of 1000, or you can here write like 366. That will be also fine, right? So now let me try to execute this query. It won't give us any error, right? So it is giving us 365 days, right? That is our requirement. So let me copy this data over here, copy this column over here, and sorry, this is the column, right? So it is giving us 365 days, right? So this is very powerful thing. This can be useful in Power BI as well, while creating the date table with only one column, which is a date column, right? So this is a very power, this is, we can say that hierarchical queries or recursive queries, we can say that, right? Now this thing we have shown already in the above one. So now let me show you another query in which I am showing you. So let me copy this data, sales data, select star from this table, right? Okay. So we have this particular table in which product name, category, and sales columns are there, right? Now our we need to, let me execute both of these query together. So now our requirement is we need to do the sum of category, category wise we need to do the sum of sales, right? So 2000, 3000, and then 5000 for category 1, and category 2 is 4000, 5 6 600, 5000, right? So over here this we can simply achieve by the group by clause also, right? Like let me show you over here, category, then sum of sales as total sales, then group by category, right? Let me now execute both of these query together. So it is showing the same result, right? But what I have done over here, is the, we have used the subquery in the from clause of the select statement, and that is known as a derived table in the SQL server and inline view in the Oracle. So over here you can see both of these query given us the same result, but to show you the derived table concept, I have written in the from clause, I have written another select statement from the table, and then after table this will become our actual another table, right? Inner table. So from this table now we are using this category and sales column over here, and we are doing the sum of sales and then group by category, right? So this is how we can write the derived table. Now let me show you the advanced analytical functions. So I have created the stock prices table in which stock symbol, trade date, open price of the particular stock, close price of the particular stock. Now let me show you the data. So let me show you the data. Select star from this particular table name, right? Stock prices. So now let me copy this data into the Excel file. So over here we have two different stock symbols are there, right? One is this one and another one is BXYZ. And three different days are there, and these are the open price, this is the close price. Now our requirement is we need to mention the open price for each stock symbol against each of the record, right? So for this one, you can say that 100 is the open price, right? Okay, let me show you the result. First one, so we need to mention the previous day open price, right, over here. So for that, whenever we want to use the previous day any of the value, at that time we are using the lag function. Now lag, in the lag function we need to give parameters. So which column previous day value we want to see. So open price, we want to see the previous value of open price, right? Now one. So we need to jump to one step only, right? One step previous. So that I have written the one over here, then over partition by stock symbol, order by trade date. So now let me show you. This is the 1st of April 2023. So we have no data of 31st of March, right? So open price will be over here, will be null. Now 2nd of April, what will be the previous day open price? So we are writing the open price over here, that will be 100. Now what will be for this one? It is 103. Now again, whenever the stock symbol are changing, it means our partition is changing, right? So it is starting again from the beginning. So again it will be null over here. Then let me copy this one and let me copy this one. So this one, we you can say that previous day open price using lag. So always remember, lag function will be used to see the previous day value. So our results will be should be matched with the C. Null 10, 100, 103, 51, 50 and 51.5. It is matching, right? So this is how you can use the lag function. Now suppose you want to jump to the two steps. So at that time you can mention over here two. So in this particular case, it will come two times null over here, right? Because if we want to jump to two values from here, then it will be null, right? Then two values from here, so nothing is there, right? So again it will be null. Then two values from here, so 100 should be over here, right? Then again null, and 50 should be copied to here, right? So that is exactly showing over here. So this is basically requirement at the time of doing the data analysis, right? You may get to provide some kind of reports to the clients. At that time it may be possible that you need to do some comparison. So at that time you are using this advanced analytical functions. Now let me jump to the lead function. So now in the lead function we are comparing the close price over here. So now let me show you the same thing. Lead means the next value, right? Lead means the next value. So let me next close price using lead. Now close price is there, right? So over here you can say it will be 101, 101.75, right? From here, what will be the next value of this? So it is 104. So it will now come over here. Now partition is changing, right? So 52 will be over here. Now for this next value is nothing. So it should be null, right? And over here next value will be this one, and this one we need to copy again. So data should be looks like this, right? Exactly. Because this particular date we are checking, what is the next value in this case? So it is 52, right? So it is coming over here 52. Then what is the next value over here? It is 50.5, right? So 50.5. And is there any next value for this one? Over here nothing is there, right? So that is why it is coming as a null, right? And same thing you can write the step parameter, which is 1 2 3 whatever you want to require as per your need. Okay, now let me show you the first value function. So let me comment this one for now. So now we are checking the first value of open price over partition by stock symbol. So let me comment this one as well. Something is wrong. So now how you can find the first value of open price over partition by stock symbol. So as per the Excel file you can see what will be the first value of over here. It is 100, right? So you can copy 100 over here, then 100, sorry, 100 over here, 100 over here, and then whenever the partition is changing, you can again copy this 50, 50, and 50, right? So this is, you can say that first value. Let me show you the same thing in the database. So it is showing the same thing, right? 100 three times and 53 times, because first value of open price for this ACME stock symbol it is 100, and first value for BXYZ for open price which is 50, right? So that is exactly showing over here all the times. Now same thing we need to find the last value as well, but whenever we are finding the last value we need to specify this particular thing. Rows between unbound preceding. So unbound preceding means that the starting boundary is the first row in the partition, and unbound following means the ending boundary is the last row in the partition. So it will compare this particular first row as the starting boundary and last row as the ending boundary. So for that case you need to mention this statement after the order by clause, rows between unbound preceding and unbound following, right? So let me show you the result. So if you see over here 104 is the last value, right? Last value of particular close price of the stock symbol ACME. So 104 is repeating, right? And again now 50.50 is repeating to each of the row, right? Correct. So this is the last value function. Now, now again let's see one of the example of recursive city. So again as date column we want to generate, at that time we have seen the hierarchical queries, right? So over here if you see we want to print number of 1 to 100. So same thing we have done over here. Select one as number, union all, then number plus 1 we have to do, right? We want to mention 1 2 3 4. So every time we want to do the number plus 1, and then whenever number less than 100 we want to exit from the loop, and after the recursive query we want to mention select number from number of sequences, so it will print number 1 to 100, right? So this is how it is printing number of 1 to 100. So this is known as a hierarchical query. Now let me take the final example, which is of correlated subquery. So I have a table, orders table, in which order ID, customer ID, order date and total amount is there, right? Now let me show you the result of this table and copy the result into the Excel file. So now our requirement is, we want to identify the previous max order. What is the previous max order is there, right? So let me just copy this result also, or you can copy this one column only. 1 15 10 1. Okay, it is not. Okay, copy me the entire result only. So now our requirement is, we want to identify the previous max order, right? Previous max order. So 1st of March, there is no previous order is available, right, for this particular date. Now 15th of March, which is the previous max order we have. So if you see, for this particular customer, we want to identify previous max based upon the customer ID. So this is one customer ID and this is second customer ID. So 15th of March 200 is there, 10th March 150 is there, and 1st of March 100 is there. So previous max order, we can say that over here, on 15th March is 150, and 10th March is, we need to count the 1st March of, that is 100. So that is 100 will come over here. Again for customer ID to 20th March. So we have no previous max order is available, right? But for 1 April, we have previous max order is 24th of March amount, which is 200. So for 1st April, it will come 200 over here. And for 22nd March, 20th March amount, which is 150, should be come over here, right? So that is the thing we have done using the subquery. So in the subquery, we have written, actually this is known as a correlated subquery, right? Because individually we cannot execute this particular query. We cannot execute individually, right? So for each of the time, it is calculating this customer ID is matching with this main table customer ID, right? And this table's order date should be less than of main table order date. Then it will give us the max of total amount, right, for each of the customer. So it is iterating every time for each record in the outer query. So performance wise, it is very slow, guys. Correlated subquery is very slow performance wise. So we need to use it very carefully and in the very rare scenarios, right? So every time it is checking that whether the customer ID is same, then the customer ID date, what is the O2 means, O2 means this particular customer ID date should be less than outer query customer ID. So at that time only it will execute.